Just a quick word, thank you again to our sponsors. Diamond sponsors for this year are Dynatrace, Lightstep, and New Relic, and our gold sponsors, Spotify, Signal Effects, and X Matters. And definitely join us tonight. We're going to be going over to the Whiskey House, 423rd Avenue. Starts at 5:30. There are some other happy hours happening. They're terrible. This is the one you want to be at. So the Whiskey, they're sad hours. Yeah, not happy hours. So please check that out. I would love feedback. What would you like to see more of? What would you like to see less of next year? I'm Ted Suo on the internet. You can find me on Twitter or whatever. Please send me DMs. I would love to hear what you thought of this year. Okay, so all of that said, we now have an awesome Q&A session. Great. So we've got Ben Siegelman here. Ben is going to be interviewing two academic luminaries in the world of observability. Rodrigo, the aliens in the room. The aliens, yeah. Rodrigo Francesca and Raja Sambasavan. Close enough?
Yeah, good enough.
Thanks. And I'll be going around to ask questions. People in the audience, just raise your hand if you'd like to jump in.
I'm going to mostly be asking questions too,
okay.
but I'll
BHS is going to lead this one.
I'm not going to say very much. I'm just asking questions.
Yeah. All right.
Cool.
Let it rip.
Hey, thanks everyone. Thanks Rodrigo and Raja. I thought it would be good to start with a quick show of hands. Oh my God, and some feedback. Okay, good. So I was wondering if people in the room, can you raise your hand if you would self-identify as an academic? You guys need to raise your hands. Okay, there's maybe 5 or 3 or something. People would identify as being a vendor of technology related to observability. Okay, saying roughly a quarter maybe. And raise your hand if you would identify primarily as an end user of observability, like you're at a company trying to do this stuff. Cool, that's the majority. All right, so academics, pretty thin at this event. Now, I'd like a show of hands if you feel like you understand the kind of current cutting edge of academic research in this area. Literally nobody. Okay. And do you feel like you have a reasonable understanding of maybe roughly what the top 5 vendors in this space are, who they are, roughly what they do? Okay. And then last question, would you like to understand more about the kind of cutting edge of academic research in this area? Okay, so that's what I was hoping.
That's positive.
Yeah, it's very positive. So we had a cancellation today, and I thought it'd be really fun to bring. I looked at the attendee list, and I was like, oh shit, we have literally the two best people in the world to talk about the academic side of this and do some questions. And so here they are. You probably don't like talking about yourselves, as you're both such modest people, but can you just give a little background about who each of you are and how your relationship to this world?
Well, that's very kind of you. But yeah, thanks for the opportunity. I was pleasantly surprised when I walked in and you invited us to do this. So my name is Rodrigo. I am currently faculty at Brown University, and my PhD in 2007 was on observability before it was called that or anything, before it was called anything. So we had this paper called Xtrace, which kind of happened at the same time as the Dapper work at Google. And I think, it was one of the first things that kicked off this space. And we'll talk more about it as we go, yeah. But I've been working on different aspects of this on and off for the past 10 years, or more. More. Yeah. Yeah, 2007.
I met you when you were doing it in 2007, so
yes.
More, yeah.
12 years.
So once again, thank you, Ben, for inviting us up here. I think this is super cool. So my name is Raja. I'm an assistant professor at Tufts now. And I came to this role because slightly after Rodrigo, I was a graduate student, and we were exploring how to use tracing for debugging. What are the interesting ways we could cut this data, slice it, how can we diagnose different performance problems, and so on. And so we came up with a bunch of different tools and techniques to do this, and that formed the crux of my dissertation research. And then I went off to a completely different world for a few years, and then for the past 2 or 3 years, I've been back in the tracing world, and we're looking at how to use tracing for various advanced purposes as part of my research. And I think you've seen 2 of the students present today on some of the stuff.
So one of the things that makes me anxious about academic work is that there's so much of it, and it can be difficult to sift through it all. Just top 2, top 3 all-time papers related to observability for each of you, and why?
Well,
Tough one, yeah.
I'll start with the X-Trace work, right? Because that really kicked off a lot of the work in tracing. I think that's, if you look at the academic side of things, look at grad students, X-Trace is what they cite for looking at distributed tracing today. I think that it's very interesting in that it espouses a slightly different model for what traces look like than the open tracing, open telemetry world. And I think there are interesting trade-offs there. There is, I think, PIP from 2006 or 2007, which is very interesting. That was about like using traces to compare or contrast like developers' expectations, how things should work, to what actual behavior is. I think that was very cool, and they actually had a language they developed to express behavior, like developers' behavior, and compared that to actual traces. And that was before the word tracing, I think, actually was a commonplace thing. So they don't actually use the word tracing at all in the paper, as far as I know.
But they had this model already.
Yeah,
much.
exactly.
It was very similar to the span model.
And let's see, one more paper. I don't know, Rodrigo, why don't you go while I think about the paper?
I was going to say PIP as well. PIP is really cool. It's just PIP by Patrick Reynolds, so you can Google it. I think the Dapper paper was hugely influential as well. It spawned pretty much all the initial implementations. And even though I would have preferred the other model a little bit, but I think in the end they're expressing the same thing. I think an early work that was also interesting, Raja's, we're like blowing each other's horn here, but Raja's spectroscope work, which was in an STI 2010 or 11.
2011, yeah.
Was also really cool because it had this idea of, okay, I have 2 traces, let me statistically find out why they're different. So it's like a lot of the things that we're kind of seeing today, like we're already expressed there. And and I think a last one, it's definitely not a top one, but I like the pivot tracing work that my student did, Jonathan Mace, because it was the first paper that combined causal tracing that we were seeing, but with dynamic instrumentation as well. So you could express queries and change the instrumentation at runtime based on the questions that you wanted to ask. Yeah.
So I have one paper I can add to that, and it's actually very related to the pivot tracing paper, sort of. There's like an entire line of research on instrumentation quality. Like, how do you know what instrumentation should be in your system in the first place to help you figure out all sorts of problems? And the one paper I point out there is Log 20, which was in SSB just 2 years ago. And what they're doing is they're trying to figure out how to automatically figure out what's the minimum amount of instrumentation you need to differentiate all the code paths in a system, which is kind of cool. So you can basically have more informed placement of all the different log statements in your system. So I think that's cool.
I have a point of order, Raja. Don't move back at all, or you're going to die.
I know.
Okay, you know that? Okay, good. His chair is like on the edge of this stage. Also, is the speaker this thing right here? Should we move further away from that thing to get rid of the feedback? Is it good? Okay. Okay, cool. Now onto the more challenging questions. So your jobs are to advance the state of knowledge, I think, as I understand it anyway. That's the whole point, right? So what are like the major obstacles standing in your way of doing that right now? I mean, not just having the ideas, like what's making it difficult to do your work?
So one thing in this area in particular, actually quite tricky to publish research on observability and tracing and debugging in general, because the bar is quite high. Like, it has to be a real demonstrated problem, so you shouldn't be testing on systems that you pretty much invented or set up yourself, or testing to find problems that you injected. So real problems on real systems, and being in academia, it's really hard. Like, if you look at papers, like we saw a paper today, and the setup is, what, 8 nodes, right? And who here has deployments with more than 8 nodes? Right. So I think that is being able to demonstrate these things. It's very hard for us to say, oh, yeah, no, we improved our response time in this real app by 70%. Right, which is one of the quotes that you guys had today. So likewise, for example, to take microservices as an example, right? There are many open source microservices frameworks that we can download and we can develop in, but there are very few or none, no existing actual systems that use these microservices, and much less there's no load that you can shove into these systems. And so trying to write research that detects problems when we can't invent the problems and we don't have the problems is, I think, the trickiest part. So I think that's one key point where industry and academia could collaborate, right? Because I think there's a whole set of PhD students out there extremely thirsty to work on interesting problems, and having traces available of some sort, anonymized traces, I think can enable a lot of research that, instead of having data scientists in each organization working on the problems by themselves, I think we can actually advance the state of the art quicker. If I don't know, I was thinking today, right? I came up with this idea of opentraces.org that we should create, and like a repository of anonymized traces, because we want to see many traces. We want to see how they're different, so that we can test machine learning algorithms. We can test, that's, I think, the top thing that I would claim.
So along those lines, I think that certain communities have like data sets that they're out there, and the bar that they have, at least a bar, is, can you find new insights from this data set that haven't been found yet? So perhaps there's something like that for monitoring or tracing data that all of us could collaborate on to create, and that would just allow a lot of researchers to work in this area.
Although it's interesting, if you're talking about getting access to data sets, that's appealing, and that would be a good place to start. But you mentioned pivot tracing. Like, pivot tracing is a really interesting piece of work, but it actually modifies the behavior of the system in a way.
Yes.
So it's not just the data. You actually would want to be able to ideally run in a way that's non-disruptive on a production system, which obviously that's harder, but it would make it much easier to actually test hypotheses and so on, right?
Right, and I think a couple of people asked after the academic talks, can I play with this, right? So yeah, that's another, yeah.
I'm speaking a little louder.
Speaking louder.
The monitors are loud here, so it sounds super loud to you guys.
But it's quiet outside. Okay, we'll be loud.
There you go.
Okay.
Enunciate to the back row.
Got it. Okay.
This comes up in like infrastructure research for like cloud computing too, right? There's a lot of stuff that uses the cloud, and you can do a lot of research like sitting on top of AWS and using AWS services. But then if you want to modify the infrastructure itself, that's like another huge beast almost, right? And I think it's worth separating both of them. And I'm betting there's a huge class of things that can be done just if we had this repository out there and we're able to create it, and then we can worry about the infrastructure stuff too.
Yeah, I will say, I'll turn it over to the audience in a minute, but for questions. But before we do that, in terms of publishing stuff, you mentioned the Dapper paper. I don't know if you're just being polite, but that, as you know, I've talked about this with you. Like, that wasn't even accepted to any conferences. We submitted that paper to 2 conferences. It was rejected from both because it's of no scientific merit, which is actually legitimate. Like, you'd already done the X-Trace work, which is the same thing in many ways. PIP had already been published, so people are like, well, there's nothing new here scientifically. The only thing we were really adding was an experience from real data at Google.
Has worked at scale at Google, right?
And that's the only contribution that Dapper had scientifically. So I actually thought it made sense that it was rejected as a scientific contribution. But it's like, for something to actually be published for science, it has to be, I think you said it right, it's a very high bar. It's like it needs to feel credible, which means it needs to use kind of real data. And it also needs to introduce new techniques and test a hypothesis. And most of the people in industry aren't doing that, and most people in academia don't have the data, so it's a problem. Yeah.
Right. Yeah. But I think I'm optimistic. There's room for collaboration. Totally. I've talked to a few of the people here one-on-one, and I got some data, but I think it should be more widespread. Right?
Yeah. So let's take questions from the audience, if there are any. Ted can run around with this microphone.
The topic?
Sure, anything. Your question.
Anything.
So on the topic of data, when like Rodrigo and I were talking about releasing Uber data at some point, and obviously I had to go through the legal department at Uber, and the problem is no one really understands what it means to anonymize. Well, they know what it means to anonymize the tracing data, but what it means in practice, is it still decipherable in some way, right? So everyone is afraid who knows what people will be able to find through this data, even though it's anonymized. So do you have thoughts on that? Because I think that would be helpful if there are some guidelines to people to how to release the data in a...
Right, but so that's totally true. There's the famous case of the Netflix challenge data, right, that was anonymized, but people are able to correlate with the IMDb data set and find the behavior exactly of people who had reviewed the same movies, even though their names are not in the Netflix data. But I think, this is the kind of thing that if there are enough people interested, we can get together and hammer out best practices and how to do this. Yeah.
Another thing that might work actually is that sometimes if the data can't be released, right? It might be worth looking out for interns to come into these companies and try out these things at scale, because I feel like a lot of the internships tend to be focused towards undergraduates, right? Or they're coming in to get different experiences. Whereas if there were focused internships, they were oh, look, cool, you come up with this academic solution to something. Why don't you come in here and see if you can get it to work here? We'll give you some data sets. We can't release it externally. Or you can try and run stuff on some of our systems, see what happens. I think that sort of mindset would also get around cases where you can't release data.
Yeah, and it strikes me that the results of these analyses are almost, I would say typically the results could be shared widely and it would be fine from a compliance standpoint. It's just that people don't, for good reasons around GDPR and so on, they're not eager to expose user data to, even if it leaks accidentally or can be inferred through, even if you hash things, you can still infer people, that sort of stuff. So I like that idea a lot of, it's like putting the research on-prem at some level.
Right. And I think also there has to be better communication almost. I feel like from the researcher's standpoint, from the academic conferences, what you said is entirely right. People look at this as science. It's very rigorous, right? You have to be pushing the state of the art and proving that you're pushing the state of the art. On the other side, when practitioners look at what researchers do, it feels like, the type of code we release usually are prototypes, right? They're at best a starting point for future efforts, right? So there has to be some kind of common understanding there for these type of discussions.
So, Raja, then riffing off of what you said, you kind of painted the picture of an intern maybe coming into an industry and pulling some data set just locally, keeping it in-house. Extending that, what about a partnership where that intern is working with somebody to actually put things into production in a controlled way and do those experiments that Ben was alluding to? Are there barriers to doing that, to actually making the production environment part of the experiment?
No, I think that'd be fantastic. I think from I have no issues with that. The only thing is it shouldn't be something that's going to take 7 years, right, to get to work. because the students do have to graduate in a set time frame, and they want to be publishing papers and so on, right? So there's some way to stage it, right? I think that would be fantastic.
Sure, but so something on the order of months then would work.
Or even a year, right? Like when I did my internship at Google on the spectroscope work, I actually spent a year there trying to get stuff to work. So I think that would be fine and amazing, actually.
Right here.
Hi, this is addressed to both of you. So most of the work you've been doing because of X-trace and spectroscopy has been on tracing. Have you looked on general metrics? Because there are a lot more environments that there are metrics coming out, time series metrics and other things like I've talked about. Are you looking at that as well? Because I think, Raja, you were alluding to some of the cloud-related work. I know there's been work going on in Berkeley as well. Do you look outside of tracing?
Yeah, one of my favorite papers on just regular monitoring was something that HP Labs did, I think, back in 2007, 2006, where they were actually looking at figuring out how to capture system state to represent behavior. So they're like, okay, there is a problem now. Can we come up with a good way to encode the metrics that are currently being observed in a way that that's a signature in case that problem's a reoccurrence, which I thought was really cool.
I think I may have seen that. Was it John Wilkes?
It was actually Ira Cohen who was the primary author on that.
Okay, but you're looking in this area outside of just pure tracing?
These days I focus kind of more on tracing, but we try to be aware of stuff.
Sweet.
There's one in the very back.
We got one in the back.
Hi, I have a question about, so we have these traces today, which are request-centric, and then most of the work in tracing has been to just capture more and more of this data in a richer fashion. I'm curious if you have any thoughts on, because this is like more pie in the sky kind of a thing, where people have talked about, there is some time travel based debuggers, based research. And then people have been looking at those too. Because traces are capturing the execution, I was curious if you guys ever considered like time travel debugging or applying some of those techniques to like these systems to either capture the state of the machine or like to extract trace data out of it or like something like that, something crazy. But usually recording the state of the system and then reproducing it later. And if you had any thoughts on like how does that compare to tracing, or is that even feasible? Does it make sense in production? Is the overhead too much? Anything along those lines?
So I think there's kind of a duality there, right? Because this type of time travel debugging usually assumes that you have the source code and you capture just the minimal necessary points in the execution that allow you to later reconstruct the execution. So essentially, you capture all the non-determinism that is outside of the system, right? And then you run the system again, and instead of calling a timer, you basically give it back the recorded timer value and so forth. So if you have the source code, you can essentially actually record a lot less data than a trace would, because you can regenerate the trace exactly as it would have been generated, right? But there's this trade-off. If you have 3,000 microservices, I haven't seen anyone even attempt to do this kind of time travel debugging in such a, like, it's distributed, but it's distributed development, right, in a sense. So I think it becomes really hard to do that. I haven't seen, maybe it's possible.
There's a group in the Midwest, I can't remember the names, unfortunately, this is kind of useless, but they're doing this type of thing at the kernel container layer, which allows them to reconstruct the state of the container, although it does have, I think, maybe 5% overhead or something like that. And then the other issue, of course, is that because it's at the container level, the application context is kind of gone. I mean, you can go into the container and try to figure it out, but it doesn't help with that.
But it won't be able to propagate trace identifiers, for example.
Right.
And it seems like, at least the world I'm starting to see, is that there are probably lots of issues that are like cross-layer issues, like application interacting with the container and interacting with like and the network or whatever else. And so like trying to like reconstruct state across all of that is probably going to be amazingly challenging.
Yeah. So I think we have almost no time left. Is that right, Ted?
We got time for one more question.
Is that you?
I have a question, actually. So observability data, like tracing, for example, is mostly used for monitoring and anomaly detection. But I'm curious, has there been any research for how to apply production observability to correctness or formal verification?
Well, correctness or formal verification. So well, first of all, there has been an application of tracing to different use cases. Like, Rodrigo, you have that retro paper, which is about resource attribution. So how can you figure out how to allocate the right resources to different clients based on like client IDs that are propagated along with requests. There is other debugging use cases I've seen, like specifically profiling. There was a talk today that talked about propagating like testing context. There's a paper in SOCC a few years ago called lineage-driven fault injection, where they're using a very similar technique to kind of figure out to inject really weird stuff into your system and try and build up a notion of the system state. And they have to also tag the request. I haven't seen anything about formal verification, to my knowledge.
But I think there might be room for that. Like, so if you combine symbolic execution, like you might try, okay, so looking at this piece of code, this service, these are the possible types of traces that it could emit. And you could perhaps correlate that with traces that you actually see, but I haven't seen anyone doing exactly that. But again, there are many uses of trace-like data and context propagation. And I think, yeah, like capabilities, all sorts of interesting things that you can do.
Well, perhaps a rich vein of research. Yeah. Okay, I think we're at time. Ben, do you have any final thoughts? Want to wrap it up?
Sure. Yeah, I mean, I never say no to a captive audience. Thank you all for listening. I will just say that I'm totally confident having sort of, I can't claim to have the expertise that either of you have, but I do try to follow this stuff a little bit. And a lot of the work that we're doing in industry right now, and even work that we're marketing in industry right now, is about 15 or 20 years behind the work that's being done in the academic world. And I think it would be really good for the overall trajectory of everything that we're all concerned with if we could find more ways to collaborate with nice folks like Rodrigo and Raja. So thank you very much for your time.
Thank you, Ben.
Thank you.